Let's start.
I had a question on the problem.
Yes.
It was in 5.4b,
In 5.4 part B, yes.
number 8.
Number 8. Let's take a look. If it's not similar to your problem, then you can definitely share your screen and give me your problem. So this is in practice, right?
Yes.
Okay, very good. Let's take a look. Okay, this is 5.5. I had that open for us. But we have to go to practice 5.4b. Okay, so I am getting this problem as number 8. Let's see if this is good enough. So the variable n in each exponent represents a natural number, meaning 1, 2, 3, 4, 5. Divide the polynomial by the monomial, okay? Then use polynomial multiplication to check the quotient. Is this,
Yes,
is this
very
good?
similar.
Very good. Okay, so our problem is 12x to 12n minus 6x to 9n plus 9x to 3n and everything divided by 3x to 3n. Because the denominator is only one term, it is useful to separate the fraction into 3 different fractions. Why 3? Because the numerator has 3 terms. So I have 12x to 12n divided by 3x to 3n minus 6x to 9n over 3x to 3n plus 9x to 3n over 3x to 3n. Now I'm allowed to simplify each fraction by itself because I'm simplifying factors. 12 divided by 3 is 4. Then I copy the base and I subtract the exponents because that's the rule. 12 apples minus 3 apples is 9 apples.
So we don't do anything with the n.
12 apples minus 3 apples.
Okay, I think like the extra n like kind of threw me off.
Okay, but you just have to say 12 apples minus 3 apples is 9 apples.
Okay, that makes a lot more sense.
Good. Very good. Minus 2. Copy the base. 9 apples minus 3 apples is 6 apples. Plus 3, and these are gone. Why? Because when I copy the base and subtract the exponents, 3n minus 3n is 0, and we know that x is equal to 0 is 1 as long as x is not 0. It was a very good warm-up question.
Okay, thank you.
Thank you. I'm sure not everyone got here. I did not get the chance to check. Thank you so much for the question. If you have anything else, Janelle, please. Anything else, anybody?
Question 29, but on 5A.
Very good. So you mean 5.4a?
Yeah.
Very good. And we are looking at problem 29. Excellent. So let's take a look. Let's go back. Can I close the 5.4b, everybody? I mean, I don't have to. We can stay open. And we can go back to it. No problem. So we want to go to 5.4a. And we want to preview. And we want to look at problem 29. If this is not good enough, please let us know.
It's fine. I just want to see how it's computed because I don't.
Is this okay? Use the power rules. Okay, very good. Is it close enough?
Yeah, that's close. I just want to see how it's done.
9 over 5, everything to the 8th power, and 9 to the 4th. Very good. Good. So first of all, we know that 9 over 5 raised to the 8th power means 9 to the 8th over 5 to the 8th. And then we multiply basically by 9 to the 4th over 1. When we multiply these, we copy the base and add the exponents. And the denominator is 5 to the 8th. Now, I don't know what they want. I hope they don't want us to divide that. So let's read how they want the answer. Type the answer in exponential form. Okay, so I will put the fraction line. I will put 9 Where is my 9? Okay, 9 power 12 and divide by 5 and then power and then 8. So I don't see anything else. There is nothing else we can do here. This is it. Good, very, very good questions. Anything else? Is there anything else that, again, I'm happy that you have questions, because I'm sure not everyone reached this point. Again, don't forget to register for test 3 and definitely for the final exam as soon as possible. So you can get the time slot you want and you're not left out, please. That's why I create, especially the final exam, so far ahead for my students to get what they want. Okay, is there anything else from anything else? If not, we're going back then. If you remember anything in the meantime, we can always stop. Okay, so in that case, we're going back to 5.5, which is this. But first, I would like to practice a little bit more before we get to these examples. So let me refresh our memory. Last time we looked at 3 special products. We basically have a total of 5 special products, but we only looked at 3, actually 2, because one of them is the same. So we have a plus b times a minus b. Notice that the first term is identical in both. Notice that the second term is identical in both. So what is different? The only thing that is different is one of them has sign plus in the middle of the 2 terms and the other one minus. And it doesn't matter if you write it as a plus b times a minus b or you write it as a minus b times a plus b. We know multiplication is commutative. What am I saying? 2 times 3 is 3 times 2. So the order is not important. What you have to remember here is stop foiling it. If you still continue foiling it, you're going to make progress very slowly in algebra. Please understand this is done as a squared minus b squared. First term squared minus the second term squared. There is no point. Now, if you don't notice that they are the same and the only difference is the sign in the middle, it's a different story. But you should get used to this because we get to mod 6, in which this is absolutely mandatory to understand how we get from here here. Why? Because we're going to be going backwards, and backwards is more difficult. If you understand the formula now, if you understand the pattern, going backwards is not going to be difficult.
Could you show examples with numbers?
Yes, in a moment. Yes, Rachel. I'm reviewing the formulas right now, and then we're going to put examples in. Yes. So this was the first one we discussed last time. And we have 2 more. Basically 1. Because the only difference is the sign in the outcome. So the other one was a plus b, everything squared. Please remember, this must be a trinomial. Do not rush and say a squared plus b squared. That would be terrible. A trinomial, as we know, has 3 terms. If you write only 2 terms, don't tell anybody that I was your math professor. I'm kidding. Please. So then what is the formula? And also the same thing with minus. Now what is the formula? A plus b everything squared is the first term squared plus twice times the first times the second plus the second term squared. And these are the 3 terms. The other one with minus, there is nothing I have to say about it. It's just this. And you have to understand and remember the pattern, please. I cannot stress enough. First term squared plus 2 times the first times the second plus the second term squared. Good. So now we are ready to look at examples, because we didn't look at enough last time. So here's one. 3x squared plus 4x everything squared. When you look at this binomial squared, first of all, you're going to say, or I'm going to ask you, how many terms will you have to write? And you must say 3. You can never say 2 or 4 or anything else. You must say, oh, it's a binomial squared. I must write 3 terms. This will follow this pattern where the first term is this. That's why we study the exponential rules. So we are able to square this in a blink. We are able to square this in a blink because we studied the exponential rules. So the first term squared plus 2 times the first times the second plus the second term squared. Again, if you continue foiling, you're just gonna stomp on the place in place, and you're not gonna move forward. So please, can anyone help? Can anyone give us the first term squared, please?
9a to the
Yes, 9a to the 4th plus. Now you do this. You can say 2 times 4 times 3, or you can say 3 times 4 is 12 times 2 is 24. Or you can say again, 2 times 3 is 6, 6 times 4 is 24. Or 3 times 4 is 12 times 2 from the formula, 24. And all you have to write is just copy a squared x plus. Now we have to square this and put it here. And we know how to square 4x. What do we get when we square 4x? Anybody, please? Can anyone square 4x for us? Ashley, would you like to square 4x for us? Samia, would you like to try to square 4x for us?
I need help with that. Can we do it together?
Sure. 4x everything squared is 16x squared. We discussed the exponential rules in the last few weeks. Good. Any questions? Anybody? Okay, so let's practice some more, like x minus 8 and x plus 8. What special product is this? What is the pattern, and how do we get the answer? Can anyone identify the special product for us? Anybody, please?
x squared plus 8x.
We do not FOIL. This is a special product. It's a difference of squares. And the difference of squares is this. A plus b times a minus b, or vice versa. A minus b times a plus b, which means a squared minus b squared. Is it a mistake to FOIL? No. Will you get less credit? No. but you will have tremendous difficulty in Mod 6 and moving forward. Good. Next example. 2ab minus 3, everything squared. How many terms would you write for this problem when we square a binomial?
Three.
Yes, very good. Now, you can square the first term, square the last term, and then deal with the middle term. That's fine. I agree with that method. So can anyone square 2ab for us?
Maybe 4a squared b squared.
Excellent. You know that if the binomial has minus, the trinomial will have the second term, which is negative. Leave some space, and let's deal with the last term. When we square the last term, what do we get? Or the second term squared is?
9.
Very good. Now you know that in here we have to have a 2 from the formula, a 2ab, and a 3. These all have to be multiplied. Do not put plus between those or among those. This has to be one term. 2 times the first times the second. You can write it like this. You don't have to do it in your head. But please no longer FOIL. So you can say 2 times 3 times 2. You can say 2 times 2 times 3, whatever method you like, but just tell me what is the middle term.
Would that be 12ab?
12ab, excellent. That's it. 12ab. Very good. Okay, let's take a look at 6y plus 1, everything squared. How many terms would you write? How many terms would you write, please?
3.
Yes, 3 terms. Write the first term, write the last term, and then think about the middle one. That is good. That is an acceptable method. Foiling at this time is no longer acceptable. Will you get credit? Yes. Will you get full credit? Yes. But you're making your life very difficult moving forward. Please understand that. So can anyone give us the first and the last term? And of course, after you finish, you can just simply cross it out. That's fine. So can anyone give us the first term and the last term, please?
Um, 36y power of 2.
Yes, very good. And there is plus, because there is plus here, I have to have plus. And the last term, there is no discussion. The last term is always positive. Good. What will that be?
The last one is 1.
Perfect. And now we know that the middle one has to be 2 from the formula. First term is 6y. And the second term is 1. Write it like this, then cross it out and put it where it belongs.
12y.
12y. And then you can simply cross it out. Good. Here's another. 9p minus 5/9 z squared multiplied by 9p plus 5/9 z squared. Is this a special product? If it is, which one?
Difference of squares.
Excellent. So when you say the difference of squares, you know you're gonna give me 2 terms. Excellent. Because how did we find out? They are identical. The only difference, and that has to be there, One is negative and one is positive, and the order is not important. Good. So we are going to square the first term. Let's see what we get. And then we're going to square the second term. Let's see what we get. We study the special products just for this. Not only, but for this short term. Can anyone give us the first term squared? Brianna, will you give us the first term squared? Alan, will you give us the first term squared? Anybody would like to give a yes? Go ahead. Please. Alan, go ahead. You're muted, so I can't hear.
I was gonna say 81p squared.
Excellent. Very good. Can anyone, thank you. Can anyone give us the second term squared? Anyone, please?
Is it 25, negative 25 over 81? Z over 4?
Excellent. That's it. First term squared minus second term squared. Very good. Awesome. Well done. Good. Moving on. So let's say y to the third plus 1/4 t everything squared. First of all, let's establish how many terms will we have to write.